Okay, Assalamualaikum and very good morning to our lecturer. We are from Group 1 would like to present about hexagonal closed pack structure. Before we start, I want to introduce our group member. My name is Nur Khadijah binti Abdullah, Amy Shakini binti Mustafa, Spencer Gani anak Andrew, and last Nur Amira Izanti binti Supardi. Next, for introduction, the hexagonal closed-pack HCP crystal structure is the one of the most common way for atom to arrange themselves in metal. HCP is one of the most stable crystal structure and has the highest packing density. After that, hexagonal closed-pack HCP refer to layer or sphere packed so the sphere in the alternating layer overlay one another. Lastly, hexagonal closed-pack is a slip system which is a closed pack structure. After that, this slide is an example of hexagonal closed pack structure. The HCP crystal structure is based on the various lattice of the same name with one atom per lattice point at each corner of the hexagonal prism, and it has three inside the prism. Next, hexagonal closed pack crystal structure. As we can see, surface at A is equal to surface at B, but the surface at A and B do not equal at surface at C. The HCP unit cell can imagine as a hexagonal prism with an atom on each vertex and three atoms in the center. HCP also have 6 atoms per unit per cell. It also can be imagined as a stacking three closed-packed hexagonal layers such that the layer and bottom layer line up.
Okay, next is the hexagonal closed pack HCP, which is it have a 12 coordination number. If you can see at the slide, it have a blue color, which is it was a nearest neighbor NN, and the red color is next nearest neighbor NNN, and the green color is next nearest neighbor. We can call it also NNNN. And for this, we have made our HCP structure model. If you can see here, we have 17 atoms, and 3 atoms is in the center. And for this HCP structure model, we have 6 pairs in the side and 1 at the bottom and 1 at the top. Okay, for the advantage of HCP, the hexagonal close packing, or HCP in short, is one of the two lattice structures which are able to achieve the highest packing density of 74%. And this packing structure is found in the metals such as zinc, cadmium, cobalt, and titanium. This is the differentiate of crystal structure between BCC, FCC, and HCP. For the number of equidistant nearest neighbor, for BCC is 8, and for FCC and HCP is 12. For the nearest neighbor, for BCC is at the corner of the cube surrounding metal atom in the center. And for the FCC, it have the same nearest neighbor, which is the atoms packed like stacked cannonballs or billiard balls in layer with a 6 coordinate arrangement. Okay, this is we continue with the crystal structure. It was from the square packing and it shift half the atoms over. Then it will build a centered packing. For the atoms in the metallic crystal, it have a tendency to pack in dense arrangement that fill the space efficiently. Then the simple square packing, just like the above diagram, which the simple cubic structure is best in inefficient and thus rare among metallic crystal structure.
The difference between FCC, BCC, and HCP is example of this FCC element at the room temperature is such as aluminium, calcium, copper, and for the example of BCC element at room temperature is iron, lithium, chromium, and for HCP is magnesium, cobalt, and also the titanium. Okay, the differentiate between BCC, FCC, and also ICP through the definition is BCC is a body-centered cubic close-packing structure of lattice, and FCC is a face-centered cubic close-packing structure of lattice, and also the HCP is a hexagonal close-packing structure of lattice. For the repeating the structure is for the BCC structure cycle among three layers, and for the FCC is structure cycle among the three layers. And also for the HCP is cycle among two layers, and for the similar layers is specific layer do not touch each other is atom touch for atom in the layer above and for atom in the layer below it for the BCC. And for the FCC, the third layer is different between the first layer, and for the HCP the third layer is similar to the first layer. And for example, the for the BCC is iron, tungsten, chromium, and beta titanium, and for the FCC is aluminum, copper, gold, lead, silver, and platinum. Also for the HCP is cobalt, cadmium, zinc, and the paste of titanium. The mechanical properties for BCC is a third common packing arrangement in metal, and each of the corner atom is the corner of another cube. The corner atom in each unit cell will be shared among 8 unit cell, and for the FCC is each of the corner atom is the corner of another cube, so the corner atom are shared among 8 unit cell. 12 of its atoms are shared. It is said to have a coordination number of 12 for the FCC, and for the HCP is the HCP structure has 3 layers of atom, and the middle layer has 3 atoms nestled in the triangular groove of the top and bottom plane.
Okay, next for the differentiate between BCC, FCC, and HCP in interstitial sites. For BCC, it has 6 octahedral voids located at the center of each face of the unit cell. 12 further ones located at the midpoint of each edge of the same cell. And then 24 tetrahedral voids located in the square spacing around each octahedral void. And for FCC, half of the tetrahedral are filled by ions of opposite charge. And the structure that form is the zinc plate crystal structure. And then the structure that form is the fluoride structure or anti-fluoride structure. And the structure form is the rock salt structure. Next, for the HCP, half of the tetrahedral sites are filled by ions of the opposite charge, and the structure formed is the crystal structure, and the structure that formed is the nickel arsenide structure. Okay, next, this slide is show the example that relate in the manufacturing industry. For the hexagonal closed pack, for example, titanium. Titanium is typically used for airplane parts and a fastener, while cobalt is also used to make an airbag in automobile and as a catalyst for the petroleum and chemical industry. Okay, next for the face center cubic or FCC, we have a chromium. Chromium is used to harden the steel and to manufacture stainless steel. The stainless steel will not rust, and it to produce several alloy. And next example is tungsten. Tungsten is current used as an electrode that are used as a heating element and a field emitters and as a filament in a light bulb and cathode ray tube. And next for the BCC, which is a body center cubic, we have aluminium. Aluminium is used in a huge variety of products including cans, foil, kitchen utensil, window frame, beer kegs, and aeroplane parts. Next is copper. Copper is such as silver is invaluable to a solder and also a brazing alloy, batteries and using in dentistry and glass coating, LED chips in medicine, nuclear reactor, photography, photovoltaic, solar energy and RFID chip. Okay. That's all from all of us. Thank you. Assalamualaikum.